Our final section in Chapter 1 is 1.6, all about polygons. And so that brings us to the first definition, polygon. And we have this that would be considered a polygon. I'm going to break this into two pieces. Polygon, yes. This is not a polygon. This is not a polygon. Not, yes. Okay, so a few things we want to consider. A polygon is first of all a closed figure, which means this would be an open figure. It doesn't have that final side to close it. This is a closed figure. This is a closed figure. However, there is another issue here. A polygon is a closed figure that has non-intersecting straight sides. So this is a closed figure, all the sides are straight. This is an open figure, automatically out. This is a closed figure with one straight side and one curved side, so this is not a polygon. So a closed figure that has non-intersecting straight sides. Now, if we talk about the non-intersecting, this would be intersecting. So these two sides are intersecting each other. So that wouldn't be one polygon. That would actually end up forming two polygons. This polygon here and this polygon here. So as a whole, that's not a polygon. Okay, so a closed figure that has non-intersecting straight sides. There are two types of polygons. You can take all polygons and split them into these two categories, either concave or convex, one or the other. Okay. When you think of concave, think of the word cave. What creates a cave? If you have a flat wall, there'll be no cave. But if you cut out a piece of the wall, now you have a cave. So when you're cutting something out, it's like an indentation. So I use that to help you remember the difference between concave and convex. Concave is a polygon with indentations. Okay, so for example, concave would be something like this. So it's got an indentation right here and an indentation right here. This would also be concave. There's an indentation here and an indentation here. So a polygon with indentations. Convex is a polygon without indentations. This is a convex. This is convex. This is convex. No indentations. Okay. This is convex. Okay. So some examples there. A polygon without indentations. Now a regular polygon, you probably should be familiar with this definition, but if you're not, okay, regular means that all the sides and all the angles are congruent. All the sides and all the angles are congruent. Now let's look at a square. All four sides are congruent. All four angles are right angles. That's one regular polygon, probably the most popular regular polygon. A regular hexagon has 6 sides. All 6 are congruent. And all 6 of the angles we could mark with an arc to show that they're congruent. So it's a polygon with congruent sides and angles. However, if we think about, there's one other piece there. It has to be convex without any indentations. Because let's look at this piece. Let's suppose all of these sides were congruent. That's possible. But these 4 angles are acute angles. They could all 4 of them be congruent. However, once you put an indentation into a polygon, you are now creating an obtuse angle. So there's an obtuse angle here that could be congruent to this obtuse angle, but there's no way it could be congruent to these other acute angles. So as soon as you add an indentation into a figure, you're now changing up the measures of the angles. So the other thing we need to add is it must be convex in order for that to work out. Our final definition is perimeter. Perimeter is just what you get when you add up all the sides of any figure, any polygon. All right, so for example, I have an example here. I have a triangle. These 2 segments are marked congruent. This one says it's x plus 3. This one says it's x. Now if that one is x, then this one's automatically x. So if I want to write an equation, I do x first side plus x, which is the second side, plus x plus 3, which is the third side, and I can set it equal to the perimeter, which is, in this case, 27. And then, of course, you can use algebra to solve that. So to find the perimeter, you just add up all the sides, and if you know what the perimeter is, then you can set that algebraic expression equal to whatever the perimeter is to create an equation which you can solve.